Hello, today we are going to see finite representation of a language. Prior to that, we'll see what is finite representation of a language. Any representation must itself be a string, a finite sequence of symbols over given alphabet set sigma. And remember that every language have uh, its own representation. Means different language have a different representations. For these set alphabet set say sigma star of a string over given alphabet sigma is a countable infinite. So number of possible representation of a language is countably infinite. On the other hand, I can say the set of possible all languages over a given alphabet set sigma, that is a power set of a given alphabet set, is uncountably infinite. With only a countable number of representation and uncountable number of things to represent, we are unable to represent all the language finitely. So no matter how powerful are the methods we use for the representing a language, only countably many language can be represented. To begin our study of finite representation, we consider expression. What is expression? It is a string of symbols that describe how language can be built up by using the operations. Let's say L is equal to some string W belongs to 0, 1, or we can say alphabet set is a 0, 1, such that W has 2 or 3 occurrences of 1s, the first string and the first and second of which are not consecutive. The language can be described using only singleton set and the symbol. Today we'll see finite representation of a language. What is a representation of a language? How language can be represented? Any representation must itself be a string. That is what a finite sequence of a symbol over given alphabet set sigma. There are different languages and it have different representations as well. That means every language have its own representation. Suppose, let's say for a given alphabet set, sigma star of a strings over alphabet sigma is a countable infinite. So number of possible representation of a language is countably infinite. As we know that there are different outcomes of the given alphabet set. Under the alphabet set, that may be in uncountably infinite string. Or I can say on the other hand, the set of possible all languages over a given alphabet set, as we know, it is a power set of a sigma star, which is uncountably infinite, with the only countable number of representation and the uncountable number of things to represent, we are unable to represent all the language finitely because of this rule, which says that over a given alphabet set there may be a uncountably infinite outcome, right? So no matter how powerful are the methods we use for representing a language, only countable many languages can be represented. Here our main concern is only on countable, as we are going to study further finite automata, which may generate uncountable or we can say it has a number of strings that are countably infinite. So how to represent that language? We are going to see how to represent a particular language. To begin our study of a finite representation, we consider expressions. It is nothing but a strings of symbols. That means over the given alphabet set. It may be binary, it may be alphanumeric, only alphabets are there that describe how language can be built up by using the operations. As you already discussed or studied that in the discrete mathematics, I hope you are familiar with the set operations and all. And let's say L is a set of things W which belongs to 0 and 1. I can say 0 and 1 is the alphabet set, sigma in this case, which contains strings such that each string W has 2 or 3 occurrences of 1, the first and second of which are not consecutive. So how could I use my language representation method here? How to represent this English statement into the some representation format? The language can be described by using only singleton sets and some symbols like union, concatenation, star, for example, or such that the given expression, English expression or mathematical statement can be written in this representation form. We want 2 or 3 occurrences of 1. So there may be compulsory 2 or we can say 3. So we need a union operation here, and again we need to find out such that first and second of which are not consecutive. That means that we will be preceded and followed by the 1. So first one is any number of zeros followed by 1 and again any number of zeros which is concatenated with, this is first occurrence of 1. Now we are going to search for the second which should be concatenated with the second one. 0, 1, any number of zeros again. So here we got the 2 number of ones. There we say 2 or more occurrences. So it may be contain 2 or more. So for the second case more, we need to again concatenate that with for one more one. So how will be that? Here there is no condition. We are only talking about first two. First and second of which are not consecutive. So they are preceded, or this is how it is written. And which is third one, if occurs, it is concatenated with 1, again concatenated with any number of zeros. Or sometimes there may be a 5. 5 is for such cases, if that string contain only 2, then this will be 5. Or it may contain more than 1, means 2 we can say. Right? So this could be written like this by using union, concatenation or star operation. So there is another way to write, as we know that two string concatenated with this symbol can, if it is not written, still it is considered as a concatenation only. Right? Along, if you exclude that, again there is no need to write the parenthesis. If you observe, we have written parenthesis, curly braces here for every individual symbol. So there is no need to write it. I can exclude curly braces and the concatenation symbol. Then we'll get new expression like this. L is equal to, by removing curly braces and the concatenation string, it looks like this. And this is called as a regular expression. So what do you mean by regular expression? The regular expression over an alphabet set are sigma star. All the string over the alphabet sigma union, there may be set of symbols like parenthesis, theta, union, star that can be obtained as follow. In short, how to represent a regular expression? Regular expression doesn't contain only alphabet set sigma, but it also contain maybe parenthesis, theta, union and the star. We'll see later on what is the symbol star. Actually, it is called as a closure. We'll see in the next topic. So, how to represent a regular expression, how to write a regular expression, the rules are given follows. Theta or phi, I can say, and each member of alphabet is a regular expression. What is phi? It is empty set. That can also be a regular expression. The language which doesn't contain any element, it is an empty set, that is also one of the language, or also can be represented with the help of regular expression. Suppose if alpha and beta both are the regular expression, then so is the alpha concatenated with the beta. If alpha and beta are regular expression, then so is alpha union beta. Fourth rule says that if alpha is a regular expression, then so is the alpha star. Nothing is regular expression unless it follows from 1 to 3. So to write a regular expression, you are supposed to follow only these 4 rules. If it belongs to one of the 4 category, then it is called as a regular expression. Right? So let's see. There is a relation between the expression and the language they represent is established by a function L. Suppose if any alpha is a regular expression, then L of alpha is a language. Now what is the relation between the language and the regular expression? Why we are talking about regular expression and the language? Is there any relation? Yes, of course there is a relation between the regular expression and the language. As we are studying finite representation of a language, we are using the regular expression. So, suppose then L of alpha is a language represented by the alpha. The function L is defined as follow. L of theta is equal to L of phi is equal to phi. What it means? The language doesn't contain anything. That means that set is an empty set. That also become a one language. Can be represented with the regular expression only phi. And suppose L of alpha for each alpha belongs to alphabet set, that is also one language. For example, if your alphabet set is 0, 1 and you say language over the 1 is output again only single 1. If alpha and beta are the regular expressions, then how to use it into the language, how to represent that expression or what that expression says, how I come to know what is the language of that expression. So language of L concatenated with beta is the same language we will obtain after language of A concatenated with the language of beta. If alpha and beta are the regular expressions, then language of alpha union beta is nothing but language of alpha union language of beta. If alpha is a regular expression, then L of A star is equal to L of A bracket star. Right? Let's see one example. Every regular expression is associated with some language. As we are right now discussed about, if there is a alpha is some irregular expression, then what is the language of that? L of alpha. So based on this expression, tell me what is the language of A union B star A. So how I come to know what this regular expressions talks? How should I convert into my English language? First of all, you should find out the meaning of this language by using above 4 rules. Applying these 4 rules, we